Hello, and welcome to a demonstration of NRAO's ALMA User-Defined Imaging service. In this demonstration, I'm going to show you how to request a CAT-NO molecular line image of the protostar HOPS 370. To access this service, you need to go to the NRAO archive at data.nrao.edu, which I have highlighted in the address bar. In order to make your image, you need to search for a dataset of interest. You can either do a text search, or you can make use of this expanded search interface to more narrowly define your searches. Since I know what target I want to image, I'm going to type in its name. So I've typed in HOPS 370. I'm going to execute my search by hitting enter. And the search results show the projects that have observed this target. To obtain more information about each project, you click on the plus signs located on the left side of each row. I'm going to select this project. And it brings up additional information about the project, the abstract, PI, co-authors, but you also see the observations that were conducted as part of this project. This project only has one set of observations. And you can get more information about the observations by clicking the downward facing arrow on the left side of the row. Now the additional information shows me the list of targets, and HOPS 370 is there. I'm looking for the CAT-NO molecular line, which will fall into this spectral window right here. So this observation has the data that I'm looking for. I'm going to make an image of it by clicking the button labeled Re-imaging. This brings you to the ALMA User-Defined Imaging interface. You need to fill out this form to submit your request. You start by filling out your email address. If you are already logged in, this field will be populated. Then you select your spectral window. I'm going to select the spectral window containing CAT-NO. Then you need to select your target, and I'll scroll to HOPS 370. Next, you can request higher or lower angular resolution. Note that you might not get exactly what you request because the imaging pipeline will simply get as close as possible within the limits of what the data allow. I'll request modestly lower resolution, but if you decide to go back to the default, you just click on the Use Default text that appears below. Now you need to decide if you want to make your data cube in frequency or velocity space. Frequency is selected by default, but I prefer to use velocity, so I'll click on that, and the interface will change. The next thing you will need to know is the rest frequency of your spectral line. My rest frequency is saved from previous input, so I will select that. But if you don't know your rest frequencies, you can use a spectral line catalog service like Splatolog, available at splatolog.online, in order to search for the rest frequency of your line of interest. Now going back to the imaging interface, my rest frequency is populated. So now I need to choose the starting velocity of my cube. I choose -5 kilometers per second. I'm choosing this because I know my source's velocity is around 10 kilometers per second. And starting at -5 kilometers per second will ensure I captured a full line in my cube. But the limits for your own data will depend on your source of interest. Then you need to choose a channel width. And you need to choose a channel width that is greater than or equal to the channel width in the observations. In this case, the channel width of the observations was 0.167 kilometers per second. I want to do a bit of averaging, so I'll use 0.33. Finally, you need to select the number of channels. And if I click Validate Form right now with the default in here, I'll get an error. And that is because what I'm requesting cannot be processed because I'm asking for a cube that is larger than the spectral window can allow. So I need to reduce my number of channels. I select 100. I click Validate again. Now my inputs are valid. I can submit my request by clicking Submit. Then the request is submitted to NRAO's computing cluster. This page shows the progress of your request. You can safely navigate away from this page. You also receive a confirmation email of your request. In addition to your requested data cube, a continuum image will also be generated at the requested angular resolution. Once your image has been processed, you'll receive an email notification when it is ready for download. Processing time may not be long, depending on the properties of your dataset, but the images must go through a quality assurance process, so there could be a few days after processing is complete before your data are delivered. Thank you very much, and I hope this demo has been useful.